Hi Calculus guys, welcome to Calculus. We actually skipped Chapter 1, or at least the sections from Chapter 1. We're going to immediately go into Section 2.1. And Section 2.1 deals with what is called the rate of change. Now for the most part, you can consider the rate of change as being the slope of the graph. Now we understand what it means to have a slope of a straight line. We will eventually look at what does it mean to be of a curved line. But we begin with example number 1. And what we need to do is we need to find the average rate of change of that graph over the interval 2 to 8. And so all we're going to do is we're going to find two different points and find the slope. Rate of change you can basically think of as being the slope. And so first one we're going to do is we're going to plug in the value of 2. So that'd be square root of 2 times 2, which is the square root of 4, which equals 2. So one of our points is this 2, and the result is 2. Now when we plug in the other value, y equals the square root of 2 times 8, or the square root of 16, which equals 4, then we get the point 8 with the result of 4. Now all we have to do is find the slope of this. So the slope would be 4 minus 2 over 8 minus 2, 2 over 6, which of course reduces to 1/3. So the average rate of change, the slope, is 1/3. Doing the same thing for problem number 2, we get h of t equals the sine of 4t, and we're going over the interval 0 to pi over 8. So the first thing we're going to do is we're going to plug in the value of 0. So we get the sine of 4 times 0, which of course is the sine of 0, which we all remember equals 0. So our point here would be the point 0, 0. To do the same thing for pi over 8, h of pi over 8 is equal to the sine of 4 times pi over 8, which equals the sine of pi over 2. And just like always, we remember the sine of pi over 2 is equal to 1. So our point would be pi over 8, 1. We want the average rate of change, which basically means the slope. So using these 2 points, we find the slope to be 1 minus 0 over pi over 8 minus 0, which is equal to 1 over pi over 8, which equals 8 over pi. And there is the average rate of change. Now, on number 3, we have a situation where we don't have points. And what we are asked is we have this graph, y equals x cubed minus 5x. And we have a point that is on this, which is 1, negative 4. We are asked two parts. First of all, find the slope of the curve. So we're going to figure out ways to do that estimation. And then we're going to actually find the equation of the tangent line. So realize we have a graph that looks something similar, something like this, and we want to know what is the equation of that line right there, or something very similar. So what we're going to do, we have only one point here. So what we need to do is we need to come up with points that are fairly close to this so that we can get some sort of a slope here. So I'm going to take the point 9, and when I plug in 0.9 into this, just take 0.9 cubed minus 5 times 0.9, I get negative 3.771. Likewise, another point that's very close to 1, but on the other side, would be 1.1. And when I plug in 1.1 cubed minus 5 times 1.1, I get negative 4.169. Now I actually have 2 points right around the same general area, so we can find what the slope of this would be. So that will be negative 3.771 minus a negative 4.169 all over 0.9 minus 1.1. And so that would add, and let's see, negative 3.771 plus 4.169 is 0.398 over 0.2, which when we do all the division equals negative, this would be negative 0.2, and we end up with negative 1.99. Now to me that would say, okay, you know what, that's probably fairly close to negative 2. And so I'm going to do a little bit of a rounding here. Now, as it actually turns out, there is a way using calculus to determine that the slope of this curve at this point is precisely negative 2. But just our estimation gave negative 1.99. That's pretty darn close. So we have found the slope to be negative 2. But we also need to find the equation of the line that is tangent. So we have this point, we have a slope. It's not too difficult to find the equation of the line. It'd be y minus the y value equals the slope times the quantity x minus the x value. And then we just need to clean this up. This becomes y plus 4 equals negative 2x plus 2. Subtract 4 from both sides, and y equals negative 2x minus 2. And so that would be the second part of the question. What is the equation of the line? There it is. Example 4 asks us to do several things. It says use the slopes of UQ, UR, US, and UT to estimate the rate of change of y at the specified value of x. So in other words, x equals 5. So in other words, that's at point U, or where point U is. We're trying to estimate the rate of change that's occurring there. That's the slope. Slope has been and always will be a rate of change. How fast is it going up over a certain distance going to the right? And so what we need to do here for number 4, first thing we're going to do is we're going to look at the line segment UQ. Well, UQ, I'm trying to find the slope here. So I don't want to say they equal, it's just I'm using UQ here. U looks like it's the 0.5, 6.2. And Q looks like 1.2. So I'm going to use those values and just plug it in to find the slope. So I get 6.2 minus 0.2 over 5 minus 1. So this is 6 over 4, which equals 1.5. So that's what UQ is. And if you look at the graph, that's probably not a very good estimate as to what would the slope be right at U, because that's what we're asking. So now let's look at UR. UR, we still have the 6.2, but let's see, the new y value for R looks like to be 1. And the old x value is still 5, but the new x value is 2. So we will get 5.2 divided by 3, and that equals approximately 1.7. Okay, so it appears to be getting just a little bit steeper, 1.5 compared to 1.7. So now we go to US. It's still going to be 6.2 minus, it looks like 2.2 to me. And that will be 5 minus 3, putting in the new x values. So this would be 4 over 2, or 2. Now we see, 0.5 or 1.5 and go up 1.7, then goes up to 2. Appears to be getting maybe a little bit steeper as we go along. Then we look at UT. UT is 6.2 minus 4 over 5 minus 4. So this will be 2.2 over 1, or 2.2. So it just seems to be going up in increments. So I might guesstimate the next jump might go up to 2.5, more or less. And this actually ends up being a multiple choice question, and if we look at all the possible answers, 2.5 is actually there, as the option C. Just appears just a little bit differently. Now, the final example here, which really get a break this week, but it's the first week, so I guess I don't have to be all that mean here, is to find what is the rate of change of y at the specified value of x, and x equals 1. So I want to know, what is it at 1? Well, we can't determine the slope right at that point, so I'm going to take a point right before it and a point right after it. So that's the 0.8, 1.92, and the 1.2, 4.32. And so, rate of change. That's the slope, so all I have to do is find the slope for that. So I will take 4.32 minus 1.92 over the corresponding x values would be 1.2 minus 0.8. And just doing some simplification, this is what, 2.4 over 0.4, and 2.4 over 0.4 is equal to 6. And so what do we think the rate of change is going on right there? Right at x equals 1, we're thinking it's got a slope, or it's going up for every time x goes over by 1. We're saying y goes up by 6.